Okay, today, which is the 30th, we did this the 29th and the 30th of January, we are going to talk about Pythagorean Theorem. It should not be something new. Some of the stuff will be new, but not majority of it. Okay, for Pythagorean Theorem, you should have this foldable. If you don't have this foldable, please ask for one. I have some extras this time. We're going to talk about Pythagorean Theorem first. First off, you should know that this should be a triangle right here, so make yours a triangle. And that you're supposed to know that A and B represent the legs of the triangle. And the C represents the hypotenuse. And you should know that the hypotenuse is the longest leg in the triangle. You're also supposed to know if it's a right triangle, then A squared plus B squared equals C squared. Okay. Alright, we're going to do an example on the left. I'm going to erase this because it's kind of messy when I'm doing it, writing with my finger. But you should have it in your foldable. So pause if you need to. Okay. Okay, so if you were to find x in this example, you should know that C is your hypotenuse because it is the longest side and it's across from the 90-degree angle. So you would have 5 squared plus x squared equals 12 squared. So then you would solve, so you'd have 25 plus x squared equals 144. Then you would subtract 25 on both sides. So you have x squared equals 119. Okay? So then, to get rid of a squared, you need to always remember that you're going to do the square root of the other side. Remember, I do not want decimal answer. That's what the last lesson was over, is simplifying radicals. So you would have to do a factor tree. Now, on your calculator, you would need to, if you don't know factors of 119, you need to just keep dividing 119 till you see if you can find one. 119 divided by 3 doesn't work. 119 divided by 4 doesn't work. By 6 doesn't work. By 7 works. So I would have 7 and 17. But 7 and 17 don't break down any further. They are prime numbers. So I have no pairs. So my final answer would be square root of 119. Okay, when you have no pairs, that's your final answer. Okay. Pause if you need to. I'm about to change. Okay, we're on the same foldable. Now we are talking about the converse. So you're supposed to know that converse means that you're going to flip the sentence. So this one over here is pretty much saying, and you should be able to write smaller, if a squared plus b squared equals c squared, then it's a right triangle. Okay. Alright, so on the rest of this foldable, you're trying to classify triangles based on the lengths of sides that I give you. So, first of all, you need to be able to tell if it's a triangle in the first place. To tell if it's a triangle in the first place, you need to add the 2 smaller sides and make sure it's greater than the third side. So let me repeat that. To make sure it's a triangle, you add the 2 smaller sides to make sure it's greater than the third side. So my 2 small sides on this one would be 9 and 12. And it needs to be greater than 15. 9 plus 12 is 21, which is greater than 15. So yes, it's a triangle. Once you find out if it's a triangle, you need to figure out what kind of triangle it is. So you're going to use Pythagorean Theorem. Again, I'm going to erase this because I don't have as much room when I'm writing with my finger than when I'm writing with a pen. Okay. So I would have 9 squared plus 12 squared is something to 15 squared. The reason I know 15 is my C is because the C is always the longest number, so it has to be the biggest number. So I'm going to have 81 plus 144 is something to 225. 81 plus 144 is 225. 225 is equal to 225, so that means it is a right triangle. Okay, I'm going to go to the next flap. The next flap says if C squared is greater than A squared plus B squared, then it's an obtuse triangle. Okay, if C squared is greater, then it's an obtuse triangle. So we're going to look at our sides again. We have 7, 12, and 16. So we need to make sure it's a triangle. So we're going to add 7 plus 12, because those are my smaller numbers, and make sure it's greater than 16. 7 plus 12 is 19, and that's greater than 16. So yes, it's a triangle. Remember, you need to write smaller than me. Okay. Yes, it's a triangle. And now I'm going to see what kind of triangle it is. C has to be 16 because that's the biggest number. So I would have 7 squared plus 12 squared is something to 16 squared. So I would have 49 plus 144 is something to 256. And that would make me have 193 is something to 256. And 256 is bigger. And that's my C squared, so that means it's an obtuse triangle. Okay. Alright, the last one is an acute triangle. For it to be an acute triangle, you have to know that C squared has to be less than A squared plus B squared. So let's go on this side over here. We need to make sure it's a triangle, so we have 8 plus 11 needs to be greater than 13. So that gives me 19 is greater than 13, and that is true. So yes, it's a triangle. Okay, then we need to figure out what kind of triangle it is. So let me erase this. Okay, so we would have 8 squared plus 11 squared is something to 13 squared. So we'd have 64 plus 121 is something to 169. Then we'd have 185 is something to 169. 169 is smaller, so since C squared is smaller, it's an acute triangle. Okay, this is going to be glued down on page 9 of your spiral. One little thing I need to make sure you understand is Pythagorean triples. Pythagorean triples are a set of non-zero whole numbers, A, B, and C, such that A squared plus B squared equals C squared. It's just a fancy way of saying that it has to be all whole numbers, so no decimals, no radicals, and that it has to be a right triangle. Okay? Common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. You do not have to have these memorized, but sometimes they're just a shortcut if you do have them memorized. So if I give you a triangle and I tell you that I give you a triangle and I tell you this is 5 and this is 3, if you know your common Pythagorean triples, you'll be like, oh, this side's 4. And then you won't have to do any work. So it just depends on you if you have them memorized or not. But I do need you to know the definition. All whole numbers, and it has to be a right triangle. Alright? Alright, that's it for Pythagorean theorem.